Hello everyone. I'm going to do an example of how to use the Pythagorean identities to help us find the values of some other trig ratios. So in this example, we are given the tangent of theta is equal to -8. And we also know that the sine of theta is greater than 0. And we want to find the sine and the cosine. Okay, so there are multiple ways to do this. But as I said, I want to use the Pythagorean identities to help us out. So because I'm given the value for the tangent of theta, I'm going to start with our Pythagorean identity that involves the tangent. And that is the tangent squared of theta plus 1 is equal to the secant squared of theta. Okay? So now, let's plug in what we know. So we know the tangent of theta is equal to -8. So -8 squared plus 1. That is equal to the secant squared of theta. So we get 64. And then adding 1, so we end up with the secant squared of theta is equal to 65. So right now I'm just trying to solve for the secant. So we can take the square root of both sides. And if we do that, we end up with the secant of theta is equal to plus or minus the square root of 65. Now, from our reciprocal identities, we know that the secant is the same as 1 over cosine. So this is 1 over cosine of theta. Now, let's flip both sides of this equation so we can get our cosine, which is one of the values we want to find. So the cosine of theta is equal to plus or minus, and the reciprocal here is 1 over the square root of 65. Now we do have this plus or minus here, but they did tell us that the sine of theta is greater than 0. Well, tangent is the same as sine divided by cosine, and if we end up with a negative, and sine is positive, that means cosine has to be negative. So the cosine of theta is equal to -1 over the square root of 65, or if we rationalize that, the cosine of theta is negative square root of 65 over 65. So there's our first value we wanted to find. Okay, now the second thing, we need to find the sine of theta. I'm going to use another identity to do this. I'm going to use the quotient identity that the tangent of theta is equal to the sine divided by the cosine. And then substituting in what we know, I know the tangent is -8. We want to solve for the sine, and we know the cosine is negative square root of 65 over 65. Multiplying both sides by our denominator, on the left, our negatives will cancel out. So then the sine of theta is equal to 8 times the square root of 65 over 65. And there's our two values.